Hi everyone, this is me speaking K. Shanmukha Priya from CSF section SRIT. Today my topic is all about rolling process working. And rolling is nothing but a bulk deformation process in which the thickness of the work is reduced by compressive forces exerted by two opposing balls. The rolling rotate to pull and simulate squeeze the work between. And we have different types of rollings: 2 high, 3 high, 4 high, cluster mills and planetary mills. Two high roll mills. Two high rolling mills are used for bloom billets or slab rolling. These are normally used for obtaining large change in cross sections. For every pass in reverse mill, the direction of the roller is to be changed. And the three rolling mills, in this process, there is no need to change the direction of the roller, thus minimum power is required. Bloom billet channel rail can be manufactured and it is very cheaper. Four roll milling. The four roll milling are arranged one on the other in the vertical direction such that only one metal strip can pass in between the roller and the shape change. We can observe it in the picture. The upper and the lower rolls are just for support, whose diameter is bigger than the another two rollers are held in vertical direction. One on the other, and the materials is to be passed in the between the two smaller rollers and shape change takes place. This type of rolling is available to the high thickness material where high compressive forces are needed to reduce the thickness of the material. And the cluster rolling mill, as a figure we can say that cluster mills are the type of rolling mills which has 6 or more rolling mills in the operation. It is used for the cold working metals. And planetary mills. The planetary mills are ideally suitable for the fining, grinding or hard, soft, brittle, tough and moist materials. The communication of the materials to the ground takes place primarily through the high energy impact of grinding balls and rotating grinding balls. And also rolling is divided into two types, hot rolling and the cold rolling. And the hot rolling is a metal working process that occurs above the recrystallization temperature of the material. Hot rolled metal generally have little directionality in their mechanical properties and deformation induced residual stress. However, in certain instances, non-metallic cushions will impact some directionally. Hot rolling is used mainly to produce sheet metal or simple cross sections such as railway tracks. We can observe it in the picture, the direction of the hot rolling. And coming to the cold rolling, it will be opposite to the hot rolling. And the process is the metal is fed into larger rollers that compress and squeeze it under high pressure. The process is usually performed at temperature between 60 centigrades to 180 centigrades and at an average speed of 40 meter per second. For the results, we'll get cold rolling increases the metal strength, hardness, and yield strength while also improving its dimensional accuracy and surface finish. The metal's mechanical properties change due to the strain hardening, and these can be used for the furniture, appliances, car bodies, computer, hardware, and construction products. It is used for some limited few shapes such as flat, square, round. It is not as ductile as other metals, so it is best for using that don't require flexing or stress. And there are advantages for the rolling process. Rolling offers significant advantages including improved material properties, and it can enhance the grain structure, availability to produce large quantities of metal products with constitutive quality, high production efficiency. Due to the rolling process very fast and time saving, allowing for higher production rates, cost efficiency, the rolling process is generally more cost effective for large production runs. Material versatility. The rolling process can be used with a variety of materials. High precision. The rolling process can produce workpieces with very close tolerance. And there are disadvantages of the rolling process, and that are the setup cost for creating custom roll forming tools can be relatively very high, limitations in part complexities. The rolling process may be less suitable for high complex profiles. Longer lead times, custom profiles may require detailed tooling to be designed and manufactured, which can add to the lead time. And the applications of the rolling process. The rolling process is extensively used in various industries applications such as manufacturing of shafts, rods, tubes, axles, and spindles, and producing workpieces and designs of cross sections, and gear manufacturing from gear blanks, and thread rolling of thread parts, bolts, and screws, production of bearing and turbine rings through ring rolling, and wide applications in the automotive industries, manufacturing of metal sheets, plates, and panels. These are the applications of the roll process. And thank you for giving this golden opportunity.